All right, guys, now let's start to look at some examples of graphing some inequalities and finding the solution of a system. Okay, what's a little bit different here when we're talking about solutions of a system? Well, when we talked about equations, we had one solution, which was the intersection point. We had a no solution. We had an infinite solution. Okay. Couple things that I can already tell you that you probably will not see is an infinite solution, just because a lot of those examples don't really show up. Okay. Can I make you one? Sure. But it's, once again, like you learned before, what's an infinite solution? Well, when the lines are exactly the same. So if I gave you the exact same inequality, well, what is your solution going to be? An infinite solution. So we hardly ever give those to you guys, okay, as teachers, because it's a little bit redundant. So we'll probably won't see that. We will see a no solution. We will see an intersection point. But our intersection point today is going to look a little bit different. That's one thing that I wanted to take a really quick note about today. So go ahead and put this also in your notes. So when we talk about solutions, okay, it's a little bit different than what we were talking about earlier. Okay, we are still looking for an intersection. We are still looking for an intersection, but it's actually going to be a region. It's going to be much larger. We're going to actually take our two shaded areas and put them on top of each other. And wherever they overlap, that is our intersection area. Okay? So we're going to say where two shaded areas overlap. Okay? That is your intersection area. That is your solution. Does that make sense? Okay. We also call this area the feasible region. Okay, I'm going to give you that word because it does show up later in math courses. You may even see it on any type of entrance exams into college. So I'm going to give you that. It's the feasible region where the two shaded areas overlap. Okay? So inside the two shaded areas where they overlap, any of the points in that area will work in each problem. And I'll show you what that means here in a minute. Okay, so let's go ahead and start on the first example. I am going to show you this equation in black, and I'm going to show you this one in red, just to show you whenever we overlap what that is going to look like. Okay, so let's go ahead and graph this. What do we graph first? Remember, I always like to pull out my B and my M. What is my B in this problem? You got it, -2. Okay, plot that on the y-axis. Remember, that's the y-intercept. What is my slope? 1/2. So that means to rise 1, run 2. It's positive, so it's up and over 2 to the right. Once again, I like to continue going till I run out of space, just because I like to have a very straight line. Okay, so that helps me to do that. All right. Okay, so that's step 1. We plotted our M, we plotted our B. Step 2, decide solid or dotted. What's your thoughts here? Well, look right here. Is there an extra line underneath? No. So if there's no solid line underneath, it's got to be what? It's got to be dashed. Okay, guys. A big thing that I see you guys kind of make a mistake on, which is not a mistake. You guys forget to make it dashed. If you're using a pencil, go ahead and make a solid line, and what I tell my students is just go ahead and start erasing, some spots of that solid line. I can kind of tell what you're doing. Okay, most teachers would be able to tell. Okay? All right, so let's graph the second one. Okay, it's in SI form. Let's identify our B and our M. Our B is what? A +2, which is our y-intercept. Our M is 5/2. Okay, and that's positive. Plot our B first on our y-intercept. So up to +2. And it's a positive 5 over 2. Well, if I went up 5, I'm going to run out of space, so I'm going to go the direct opposite. Okay, I was going to go up and to the right. So what would be the direct opposite of up to the right? Down and to the left. So down 5. 1, 2, 3, 4, 5. 1, 2. Okay, that's the only 2 points that I can make. So we're pretty much good right there. So that's step 1 done. Step 2, decide if it's solid or dotted. Let's look at our inequality. I have a solid line, so what am I going to do? Solid line on my graph. You got it. Okay, good deal. All right, some of you guys would be like, oh, we're done. I have an intersection point, it's -2, -3. You're thinking just equations when there's an equal sign. Great job, you're remembering, but we're not done. What is the solution to an inequality? We're looking for the intersection area. We're looking for the feasible region where both shadings overlap. So did we shade at all? No. Okay, so let's go ahead and start shading. Let's go back to the black equation up here again. We're going to pick a test point. What's the easiest one? Okay, I'm going to pick, so here's our black dashed line. Where is a good point? I like to pick the origin. Zeros are very easy to work with, so I'm going to pick 0, 0, which is on the upper half of this black line. I'm going to plug 0, 0 into our equation. So it's going to look like this. 0 goes in for y, 0 goes in for x. And now we simplified. 1/2 times 0 is 0. 0 minus 2 is a -2. So does this make sense? Okay, is this a true statement or is this a false statement? 0 is greater than -2. It is 0 greater than -2. Think about a number line. Absolutely it is. So this is a true statement. So if it is true, should we shade the true side? Let's think back of yesterday's lesson. Absolutely. When it's true, we want to shade it because it makes sense. Okay, so which side? Where is 0, 0 located? Oh yeah, it's at the top, remember? So I'm not going to fully shade so that you can still see the graph. So I'm going to just make some lines here for you guys. Okay, so everything on this side of the line over here is true. It works for this equation. But we still have to figure out what works for the red equation. So let's look at that. Same test point. Why can't we use 0, 0 again? There's no issue with that. Okay, so let's plug 0, 0 into the second equation. 0 goes into y, 0 goes into x. 0 times 5 over 2 is 0. I love zeros. They make my life so much easier. 0 plus 2 is 2. Let's see if this makes sense. 0 is less than or equal to 2. 0 is less than or equal to 2. Think of a number line. This is also a true statement. Okay, so which way would we shade on this? Where is 0, 0 located next to this red line? Well, it's everything like on the bottom or the right side. So let's go ahead and shade everything on the right side of this inequality. Okay, almost done. Check this out, guys. Where do we have a solution? Where do we have a solution? Well, when the two shaded areas overlap. So where does the black and the red overlap? That's right, look at right here. Check this out. I see some black here and red just in this area. Okay, I'm gonna make this darker for you guys so that you can see it for the first time that we do it, but I'm not gonna do this every time, okay? So everything right here, I'm gonna outline it so you guys can see it. So any points in that area, that is the feasible region. So if you picked any points in here, okay, and you plug those points into the original equations and they both check out, you found the right spot. So any points right in there, okay? So that's the feasible region. That's what you're looking for every time you do these problems. Easy enough? Yeah. The pain in the butt part is finding the regions, okay? All right, so let's try another one. So let's look at example number 2. Okay. It's both in slope-intercept form, so we can get this done really quick. The first equation I'm going to do in black, the second one I'm going to do in red. What is my b in this equation? 3. What is my m in this equation? 6. Good. Let's go ahead and plot that. Positive 3 on the y-axis. That means up 6 over 1 to the right. I'm going to run out of space, so I'm going to go opposite. 1, 2, 3, 4, 5, 6 over 1 to the left. Okay, what do you got to decide now? Step 2, solid or dotted? You got it, solid, because it has that solid line underneath. It's less than or equal to. Okay, so let's go ahead and draw our solid line, connect our dots, and we're done with graphing that one. Excellent job, guys. Let's go ahead and do our second one. What is our b in this inequality? You got it, -1. What is our m in this inequality? Once again, it's 6 over 1. Now, some of you guys will be like, oh, these are parallel, so it's going to be a no solution. We haven't shaded yet, so we don't really know. Okay, so -1 on the y-axis. Okay, 6 over 1. That means up 6. 1, 2, 3, 4, 5, 6. Hey, that fits. Okay, so let's do this. And then over 1 to the right. Okay, step 1 is done. Decide what type of line is that. What kind of thing is that? Oh, that's just greater than. So there's no extra line, so it must be, you got it, dashed. Okay, so yes, you are correct. These are parallel, but we're not done. We have to shade. That's step 3. Okay, instead of doing test points, I'm going to use the calculator. So I'm going to show you both ways of doing this. Okay, so I'm going to pull out my calculator. Make sure everything's back to the beginning here so I can show you every single step. Okay, where do we go? All right, we're going to go to y equals. Let's go ahead and type in our equation. So we have 6x plus 3. I'm going to type in my second equation, 6x minus 1. Go to the flapping arm, scroll all the way to the left. How do we change that? We hit enter. What are we looking for? We're looking for less than. So is that shaded at the top or is that at the bottom? You got it, at the bottom. Okay, now we're looking for greater than. Keep hitting enter. So we want the top because that means greater than. We're done. Now all we got to do is hit graph. Okay. Here comes our second equation. All right. It's going to be a little bit harder to see, so let's take a look at it really quick. So I can put it here where you can really see a good bit of it. Okay. So we have these shaded regions going down all the way across, okay? And we have this shaded region going this way. So on our graph, it's actually going to look something like this. So the black was shaded over here. And the red was shaded over here. Okay, where is that overlapping? It was kind of hard to see on the calculator, that's why I took it away. So where is it overlapping? Ooh, right in this strip. So this has a solution. Okay, once again, you can make it a little bit darker for your teachers, just so that we can grade it a little bit easier. But that is the feasible region. Okay, that's where if you pick any points in there and plug them in, they would check out, everything would be good to go. Okay? All right, let's take a look at a couple more examples.